Hello, my name's Maui. Today I'll be presenting how we trained an AI model to identify iris species using raw data collected from nature. Now, what if I told you that with just 4 simple measurements, we could teach a machine to identify flowers better than most humans? That's exactly what we're going to be talking about today. Using these measurements, we trained a machine to predict the iris species for new unseen data, using sepal length, sepal width, petal length, and petal width. We trained our model to categorize 3 subspecies of iris flowers: Iris setosa, Iris versicolor, and Iris virginica. But here's the real challenge. Can our model truly understand the differences, or is it just memorizing patterns? Let's find out. We use the famous iris dataset to train our model, which contains raw measurements of iris flowers collected and organized by botanist Edgar Anderson. First, we split the data into 67% for training and the remaining 33% for testing. We use the testing data to evaluate how well our model performs on unseen examples. In our training phase, we experimented with a mixture of activation functions and optimizers to figure out the most effective setup. Each configuration was tested over 20 epochs. We took those results and ranked them from best to worst based on validation performance. To get a better representation of the performance for our optimizers, we make a scatter plot. The x-axis representing the test accuracy, the y-axis representing the test loss. Lower loss, high accuracy indicate better performance. The visualization helps us identify the most effective optimizer for our task. Here we have another scatter plot, but this time we're digging into the activation performance instead. For both plots, the rule stays the same. High accuracy, lower loss. That's the sweet spot we're chasing. After evaluating different performances for activation functions and optimizers, we decided to go with the JALU for an activation function and Atom as our optimizer. So we trained our model on 20 epochs and plot the accuracy to identify the optimal number of epochs needed for effective learning, balancing pattern recognition and overfitting. An epoch is one complete cycle where the model goes through all the training data and learns patterns. If we use too few epochs, the model lacks sufficient exposure to learn meaningful patterns, leading to poor predictions. Conversely, too many epochs will cause the model to memorize answers rather than generalize from the data. Our goal is to figure out the ideal number of epochs for our model to generalize effectively. Here, 10 epochs works best, while overfitting occurs around 15. With only 50 samples, accuracy remains high, but on a larger dataset, validation performance would decline over time. After training is done, we plot our confusion matrix, showing that our model easily predicts Iris setosa and Iris virginica. However, Iris versicolor has overlapping similarities that make it more challenging to differentiate. Now, to get a better understanding as to what's going on behind the scenes, we plot a decision tree, and this shows us why the machine made these certain decisions to classify certain pieces of data and say, this is why it's this one, this is why it's this one, etc. To figure out why our model struggles to predict versicolor, let's walk through how it makes its decision. It starts by checking if the flower is Setosa. If it is, great, it's done. If it's not, then it will decide between the other two classes, which is Versicolor and Virginica. This process involves more steps identifying Virginica than Versicolor. So when we look at decision tree, it shows the model might tend to lean more towards predicting Virginica even when the flower is actually Versicolor. Now there are several ways that we could improve this model, such as increasing the dataset size, adding additional features like images or other relevant data, and fine-tuning hyperparameters. These are my recommendations for enhancing the model's performance. In conclusion, finding the optimal number of epochs is crucial for achieving a balance between learning and overfitting. While the model performs well with a small dataset, larger datasets may require further validation and tuning. Evaluating additional indicators and refining the model can lead to better accuracy and generalization. Thank you for listening. My name is Maui.